theory of evolution was advanced by Charles Darwin in the middle of the 19th century. That period greatly differed from today in terms of its extremely poor level of science and technology. Nineteenth-century scientists had to work in simple laboratories with quite primitive equipment. With the devices then available, it was impossible for them to view even bacteria. Furthermore, scientists were still under the influence of many superstitious beliefs upheld since the Middle Ages. One of these superstitious beliefs was that life had a simple form. Going as far back as Aristotle, this belief maintained that life could self-originate by the coincidental assembly of inanimate matter in a moist milieu. While developing his theory, Darwin relied on the belief that life basically had a simple structure. Other biologists who adopted and defended Darwin's theory thought the same way. For instance, the greatest advocate of Darwinism in Germany, Ernst Haeckel, supposed that the living cell, which could only be viewed as a dark spot under the microscopes at that time, had a very simple structure. In one of his articles, he referred to the cell as a simple little lump of albuminous combination of carbon. The theory of evolution was based on assumptions such as these. The pioneers of evolutionary theory, like Haeckel, Darwin and Huxley, thought that life had a very simple form, and that this simple form could originate by itself as a result of chance. However, they were mistaken. In the 1.5 centuries that have passed since Darwin's day, giant steps have been taken in science and technology. Scientists discovered the structure of the cell to which Haeckel referred as a simple little lump of albuminous combination of carbon. They saw with surprise that it is not simple at all, as earlier supposed. It was revealed that the cell has a system so complex as to have been unimaginable in Darwin's time.
The fact is that a huge number of highly complex systems in nature cannot be plausibly accounted for.
A renowned molecular biologist, Michael Denton, makes the following analogy to describe what kind of a structure the cell has.
Does not exist in the biological literature.
To grasp the reality of life as it had been revealed by molecular biology, we must magnify a cell 1,000 million times until it is 20 kilometers in diameter and resembles a giant airship large enough to cover a great city like London or New York. What we would then see would be an object of unparalleled complexity and adaptive design. On the surface of the cell, we would see millions of openings, like the portholes of a vast spaceship, opening and closing to allow a continual stream of materials to flow in and out. If we were to enter one of these openings, we would find ourselves in a world of supreme technology and bewildering complexity. Now let us vitalize Professor Denton's spaceship analogy and see the complexity in the cell closer. Our journey starts with hormones that look for an appropriate cell for themselves. When hormones approach the cell, they first look for a door that will let them in. The doors of the cell are selective in the way they operate. Every molecule stopping by a door is checked by the door to see whether it is beneficial to the cell or not. The doors open only for useful molecules. If a harmful material, such as a virus, tries to enter a cell's door, the situation changes. The cell door analyzes the material, finds out that it is harmful, and rejects it. When we enter the cell, we discover, as Professor Denton describes, a stunning technology and complexity. When hormones step in the door, they are immediately taken under control by special proteins that carry out the functions of the cell. These proteins are called enzymes. If required, enzymes immediately put the newly arrived hormones to use. If there is no need for these hormones at that moment, they are placed in the storage compartment of the cell, which is called the Golgi apparatus. Some molecules, such as the insulin that carries sugar molecules, are too big to pass through the doors of a cell.